Hello friends, welcome to our session for geometry. So let's see what we are going to do in today's session. First of all, what is geometry? Geometry is basically the study of position, shape, size and other properties of different figures. These figures may be circle, these may be lines, this may be points and so on. You can see here some of the very fascinating figures or structures that are shown over here. These are all the result of geometry actually. Now, moving ahead. First of all, point. Point is basically a mark of position. It has neither length, nor width, nor thickness. You just take a piece of paper, mark a dot using your pen or pencil, and that will be the point. Similarly, line. This line has only length. It has neither width nor thickness. So you can draw a line by two different arrows pointing in two different directions. This shows that line is extending throughout. Now two arrows drawn in opposite direction indicate that line has unlimited length, just like over here. Now unlimited number of lines can be drawn through a fixed point. Let's say we have this particular fixed point, the red dot as you can see over here. Now, if we try to draw different lines over here, it can be something like this way. So you can practically draw unlimited or infinite number of lines through this particular fixed point. Now, only one line can be drawn through any two fixed points. Let's say we have these 2 points and we can draw only one line, one and only one line through these 2 points. And every line has infinite number of points. As I've already told you that point is nothing but just a dot structure which neither have length nor width nor thickness. So we can practically have infinite number of points in a given line. Now something about ray. We all have seen the sun rays, rays coming from a bulb, rays coming from moon and so on. So ideally a straight line that starts from a given point and travels in the same direction, that is called as ray. Let's say this is one point and a ray has been originated from this particular point. Remember that in a ray we have only one-sided arrow. A ray has only one fixed point which is called as initial point. A ray extends indefinitely only in one direction. An unlimited number of rays can be drawn with the same initial point. Now we have something called as line segment. So this line segment is a part of a line as well as of ray. So we have 2 points and we can join these 2 points with a line segment. Now we have something called a surface which has length and breadth but has no thickness. And the surface may be flat or curved. And where we have a plane which is nothing but just a flat surface. Now something about collinear points. Points are said to be collinear if they fall in a single straight line. Let's say we have these 3 points A, B and C, and if we are able to draw a straight line so that it can pass through all these 3 points, then these 3 points are said to be collinear. Fine. Now let's see about these 3 more points, that is PQR. And as it is shown that PQR cannot be contained within a single line, and so the point ABC are collinear, but PQR are not collinear. Now we have something called as parallel lines. Two straight lines are said to be parallel to each other if they lie in the same plane and do not meet even when produced up to any extent on either side. That means the distance between them remains constant throughout. A very common example here is a railway track. If you look at the railway track, you will find out that it won't coincide even when it is extended from up to the length and breadth of the country. Now, we can see that we have 4 different points, A, B, and C, D, and we have these 2 lines which are passing through them. And these 2 lines are actually parallel because their distance remains same throughout their extension. Then we have something called as intersecting lines. If 2 lines in the same plane are not parallel to each other, then they are called intersecting lines. Lines are not parallel means their distances keep on decreasing. That it means that near or far they will intersect for sure, and that is the point of intersection. And you can see here that we have lines passing through the point AB and CD, and these are intersecting at a particular common point. Now we have something called as concurrent lines. If 3 or more lines pass through the same point, then these lines are called as concurrent line, and the point is called as the point of concurrence. You can see here we have a point A, B, C, and D. Now, like this, we have 3 different lines. One is AB, one is CD, and last one is EF. And all the 3 lines are actually passing through a single point here. And so these 3 lines are called as concurrent line, and the point over here is called as point of concurrence. Now we have a triangle. Triangle is a plain closed figure bounded by the 3 line segments. And this is how it actually looks like. A, B, C, these are the triangles. We have a rectangle. This is nothing but just a plain closed figure bounded by 4 line segments. And here opposite sides are equal and the angles are at 90 degrees. You can see here we have a rectangle ABCD. Here side AB is equal to CD, and AD is equal to BC. And you can see here that all the angles over here, that is either angle A, angle B, angle C, and angle D, all of them are at 90 degrees. Then we have a square. Square is basically a plain closed figure bounded by the 4 line segments. Here all sides are equal and the angles are at 90 degrees. So the only point that separates a rectangle from a square is that all sides in a square are equal. You can see the figure here, and you can see that AB is equal to CD is equal to BC is equal to AB, right? And you can see here that all the angles, whether it is angle A, angle B, angle C, or angle D, all of them are equal and equal to 90 degrees. Fine. Then we have a circle. And this is how a circle looks like. We have center point, that is O, and distance between the center and the point of a circle over here, that is any point over the circle itself, is called as radius. Okay, distance between center and the actual sketch of circle is called as radius. Then perpendicular. Perpendicular, the straight lines are called perpendicular lines if they intersect at right angles. Let's say we have a red line over here and one yellow line is intersecting that line, and the angle between the yellow line and red line is 90 degrees. This says that these two lines are perpendicular to each other. Then we have perpendicular bisector. Perpendicular bisector is basically a line is called a perpendicular bisector of a line segment if it bisects the line segment and perpendicular to it. In the same way, let's say we have a red line and we have point A and B, and we have a yellow line passing through that red line saying that there is an angle of 90 degree between them, and moreover this line, yellow line, which is intersecting red line at point C, such that AC is equal to BC, right? That means this line, yellow line, is actually dividing red line into two equal halves. Then we have something called as angle. Here a quarter turn is called as right angle. This is 90 degree in measure. An angle between 0 degree to 90 degree is called as acute angle. You can look in the figure that we have an angle BAC and its measure is constantly increasing, and it will increase up to 90 degree only because it is creating a acute angle. In the similar way, angle between 90 degree and 180 degree will be obtuse angle. You can see in the figure that we have an angle BAD which is constantly increasing or decreasing, and you can find out that it is actually oscillating between 90 degree and 180 degree. And so this is called as obtuse angle. Angle between 180 degree and 360 degree is called reflex angle. You can see here that this is actually oscillating between 180 degree and 360 degree. This is how your reflex angle looks like. Just have a look at the reflex angle and you will never forget how it is being done. Now let's move to the next point. Adjacent angles. Adjacent angles, they have a common vertex, they have a common arm, and other arms are opposite sides of the common arm. Let's say we have these two arms here, and common to the vertex we have a third arm over here. Now this red arm, that is the middle one, is common to both the arms above and below, and other two arms are opposite side of the common arm. So we can say that angle 1 and angle 2, these are the adjacent angles. Now we have vertically opposite angles. So when two lines intersect, the angles on the opposite sides of their point of intersection is called as vertically opposite angles. We can see here that these two lines are intersecting each other, and the angles which are of 50 degree and 50 degree, these are pair of one vertically opposite angle, and similarly pair of 130 degree and 130 degree, these are another pair of vertically opposite angle. So we can draw a reference from here that the vertically opposite angles are equal in nature. Just remember this point, guys. Then we have congruent angles. Congruent angles are the angles that have the same measure. That's it. Now complementary angle. Two angles are said to be complementary if their sum is 90 degree. We can have two different angles. Let's say one angle is 40 degree, one angle is 50 degree. So they are said to be complementary if their sum is already 90 degree, right? So this is how they actually look like. You can see here we have angle Kij or Jik is 90 degree, and remaining angle KIL and Lij are actually lying between these two angles, these two arms over here, right? The values are constantly changing, and since their sum is 90 degree, they are said to be complementary angles, right? So now you might have a question that, like, if one value of a complementary angle is given, we have to find out another value. Let's say we have a very common question like angle one complementary angle is 10 minus x, then what will be the another angle? So the straightforward solution for the same is just take 90 degree minus 10 minus x, right? It's just an example I've just shared with you. Similarly, we have supplementary angles. Supplementary angles are those angles whose sum is 180 degree. You can see here, like, we have angle BCD as equal to 180 degree, obviously because this is a straight line, and we have angle BCA and DCA, and their values are constantly changing, and their sum is 180 degree because these are the supplementary angles. Now, properties of the supplementary or complementary angle. When two straight lines intersect each other, then sum of pair of each adjacent angle is 180 degree. What I told you about adjacent angles, that means those angles which share the common point, common vertex, they have one common arm, and other two arms are opposite to the common arm. Another important point is the vertically opposite angles for the two lines intersecting is always equal. If the sum of two adjacent angles is 180 degree, then their exterior arms are always in the straight line. You can understand it very well. Obviously, in a line we have the angle is 180 degree, and so the external straight line will be there for that kind of angle. Then, if the exterior arms of two adjacent angles are in the same straight line, the sum of angle is 180 degrees. Right? Now, we have parallel lines. So two straight lines lying in the same plane are said to be parallel if they do not meet. Just like this. L and M, that is red and yellow line, are said to be the parallel. Now transversal line. When a line cuts two or more parallel or non-parallel lines, then that line is called a transversal line. We have line L and we have line M, and in the observation you can see that these two are not at all parallel. But however, if we cut it with a line P, then line P is called as transversal line. Now, when lines are parallel, let's find out the properties. Let's say we have two lines P and V, and we have angles A, B, C, and D. And here at the bottom part we have angle E, F, G, H. So here we have a few points would like to share with you. We have exterior alternate angles are always equal. Exterior alternate angles, that means angle A and angle H, angle B will always be equal to angle G, right? Then interior alternate angles are also equal, that is angle D will be equal to angle E and angle C will be equal to angle F. Similarly, corresponding angles, that means angle A will be equal to angle E and angle C will be equal to angle G. And in the similar manner, angle B will be equal to angle F and angle D will be equal to angle H. Similarly, co-interior angles are always supplementary, that means their sum will be 180 degrees. So angle C plus angle E will be equal to 180 degree, angle D plus angle F will be 180 degree. And in the similar way, we have angle B plus angle H will be equal to 180 degree, and angle A will be along with the angle G will sum up to 180 degree. So just remember one very small point, just try to understand or learn this concept by heart so that you can answer the question just by observing a given figure. Okay? Thank you so much. Have a happy learning and have a nice time. Take care of yourself. Bye bye.